Let's move forward and go and finish those last ones that we were looking at in the previous session, shall we? I've got here, we did that one. Now I want to do a slightly different one. Okay, I want to do one that says, okay, here's an example. This is example 5. Okay, example 5 was this: 2 cos 2 theta minus 15 degrees equals 1.5. Right, step 1 is isolate the trig function, because only when I've got it to the basic trig function can I apply the opposite. I can't do the arc cos here because there's a 2 times in front. So I reduce that down to 2 theta minus 15 degrees equal to that divided by 2, 0.75. Then I take the reference angle is going to be arc cos of both sides, remember. Let me actually just do it. Okay. Let me just take a little bit of time. What are we doing? We're doing arc cos of 2 theta minus 15 degrees. We call this the reference angle, correct? All right, it's going to be that, isn't it? Okay. So therefore, in effect, what am I left with? I am left with 2 theta minus 15 is the subject of my formula. Okay. Let me just take this out here. This is equal to the reference angle, which is equal to arc cos of 0.75, which is going to be equal to 41,41 degrees. Oops, just get you out the way there. 41,4. It always does that. That I'm going to definitely mistake for a 41 degrees. Okay, so that's the reference angle, right? But you can see here, just on the side, the arc cos of that, so 2 theta minus 15 is equal to this whole thing, isn't it? That's my solution. Okay, so therefore, what do? I say the next one is the type. Now you don't put that equal to it, but that's my subject of my formula now. The type is cosine. Therefore, the general solution of cosine is going to be equal to 2 theta minus 15 degrees is equal to plus minus RA plus 360K, which is plus minus 41,41 degrees plus 360K. Okay. 2 theta minus 15 is equal to that. Okay. Therefore, I have to split 2 theta minus 15 degrees is equal to plus 41,41 plus 360 degrees K, and 2 theta minus 15 is equal to minus 41,41 plus 360 degrees K. Sorry, these get really long. You ain't seen nothing yet. We're going to get some that got 4 answers, okay? I'm actually going to run out of paper to do it. We get here. You can see now, I must now add 15. So that's 2 theta is equal to 15 plus 41,41 plus 360 degrees K. And 2 theta is equal to minus 15 degrees minus 41,41 degrees plus 360 degrees K. Therefore, 2 theta is going to be equal to 56,41 plus 360 degrees K, and 2 theta is going to be equal to minus 26.41 minus plus 15, you silly sausage. Okay, minus 26.41. Okay, plus 360K. Right? Sorry about that. I took it over as a minus. Okay. And now we continue and we say, therefore, theta is equal to, and what do? We divide by 2, and we divide everything by 2, because you cannot just divide the beginning one. So theta is going to be equal to 28.21 or comma 21 degrees plus 180 degrees K, and theta is equal to minus 13.21 degrees plus 180 degrees K. Okay? Those are my two answers. And lastly, K element of Z. Okay? Let's look at a tangent. 2 tan 2 theta. This is example, I don't know, I've got it as example 6. Right? Doesn't really matter. Okay? Let's do it as example. Example 6. Find the general solution of 2 tan 2 theta equals 3 cos 30 degrees. Whoa. What's going on here? I've now got a trig function on the right-hand side. And I put the note here and I keep saying, follow the recipe. Follow the recipe. Okay, what does it say? It says, isolate the trig function first, correct? Which is therefore tan of 2 theta is equal to 3 over 2 cos of 30 degrees. Then you recognize that cos of 30 degrees is a number. This is actually guys, it's a number. So if they put it there, it's a number. You can work it out. You can find that. Because what do I say? I say reference angle is equal to angle whose tangent arctan, tan to the minus 1, inverse tan, is going to be 3 over 2 cos of 30 degrees. And if I put that in my calculator, I get what? I get arctan of 3 over 2 times cos of 30, 0.866, right, equals inverse tan, 1.299, and the final answer comes to 52.43. Okay, so it's no sweat. You just follow the recipe. That's all you have to do. Okay? No more, no less. Okay. Then we say, okie dokes, we've got that now. We say, cool. The type, remember we said the type is tangent. Therefore, general solution, if you wish, general solution is going to be, theta is going to be equal to RA plus 180K. Like so. But in this case, it's 2 theta. Therefore, apply it, and you got 2 theta, because why? Because, going back again, remember what we started off with? Let's go blue. That was the new subject of the formula, is it not? Okay. So 2 theta is going to be equal to RA, which was 52.43 degrees plus 180K. Then divide by 2, right? And where's the mistake I'm going to make? We generally forget to divide that character as well. Okay, and we lose a huge amount of marks. Theta is going to be 26.21 degrees plus 90 degrees K. And lastly, K element of integers, like so. All right? Now, so that's the recipe. By now, you should have written the recipe down, and you should be comfortable with the recipe itself. Okay? What to do? Isolate the trig function. Okay? take the opposite, the inverse of the trig function of the other side to get the reference angle. Then you decide what type, if it's sine, cos, or tan, and you apply the three different pieces, putting whatever's behind in that bracket. Remember, if it's 2 theta plus 20 degrees, that becomes equal to the RA plus or minus or whatever it is, correct? Then you take the degrees across and then divide either by the 2 or the 3, or if it's a half, you're going to multiply by 2, okay? Those are straightforward. Now let us look at this restrictions of domains, okay? Restricting domain. What's this all about? Well, essentially, guys, it's this, all right? In the solution of the equations, okay, you're going to get a whole bunch of possible answers, all right? When they say to you, solve it with a restricted, they are going to say to you, I only want solutions between, let's say, minus 180 degrees, less than or equal to x, equal to 180 degrees. In other words, they only want solutions where x is in between there, or theta. All right? In other words, only angles that fall in there for a solution. I don't want solutions of 797 degrees. Okay? I only want the ones that fall between there and there. So on a restricted domain, okay, right, we restrict the domain, the x values, to be the area of the interest. We exclude all the other possible solutions. That makes sense. We're only interested in that piece of the curve, okay? Okay, how do we approach these using a restricted domain? We're going to draw up a table, all right? And essentially, we're going to have the table of k, and k can be minus 2, minus 1, 0, 1, 2, or whatever, okay? So we use various values of k. Various values of k. Go there. And over here, we've got theta and theta. In here, we've got the equation for the general solution. Right? That's the equation for the general solution. Remember, you can have two, a plus RA, plus 360, and a minus RA. Okay, plus 360. Or whatever it is. Then you apply k to it, and you get answers in here. All right? You get values. We're going to do examples, plenty of them. Okay? Like so. You get examples, right? Then you go ahead and you look. Okay? You go and you have a look, and you say, right, which ones of these fall inside this domain? No, 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 yes. Yes, maybe. No, no, maybe yes, yes, no. Right? In other words, your values are the ones that give you the answer that you require. Okay? Let's just have a look. I don't know if I've done an example. I have. Okay? Let's just look at an example of these. All right? Let's go back to black. They say, usually k from minus 2 to 2. Okay, you don't usually get k's of 3s, 4s, or whatever, all right? And let's have a look. 2 tan 230 equals 3 cos. I am using the same equation or the same one as I used last time. I'm going to be using this, okay? Find the specific solution for this. 2 tan 230, 2 tan 2 theta equals 3 cos of 30 degrees, okay? All right? And we've previously done it, all right? And we got an answer to it, right? Now, previously the answer we got was theta equal to 26,21 plus 90 k element of z, okay? Now, what did I say we do? Okay? Let's take this and slide it down, because I'm now going to draw a table with various values of k. Okay. So I said we draw a table and we put k. And I started -3, -2, -1, 0, 1, 2, 3. Okay. Over here, I put my theta. Theta was 26.21 degrees plus 90 times k. Up until this point here, let me just make it clear. Up until this point, you solve as per usual. Okay? Find the general solution. Okay? Then we apply different forms of different values for k. In this case, I'm going to put there's my equation, and now let's have a look. I say here, this is therefore going to be 26,21 degrees minus 3 times 90, which is minus 243.79. Correct? This is going to be 26.21 minus 2 times 90. Can you see I am inputting values of k? Can you see that? K is minus 3 minus 2 over there. And that gives me an answer of minus 153.79 degrees. This is 26.21 minus 90 degrees, which is minus 63.79. Okay? 0 is 26.21 degrees. Please don't forget 0. 26.21 plus 90 degrees is 116.21. 26.21 plus 180 degrees is equal to 206.21. And lastly, it's 26.21 plus 3 times 90 degrees gives us 296.21. Okay. Now I go and I check domain. Check versus domain. Okay. What do I mean by check versus domain? Okay. The domain that they gave us, right, was this. Okay, keep it in blue. So what did they say? They said any angle, theta, x, whichever, any angle that lies between minus 180 and plus 180, any angle in there is acceptable. Okay? Anything outside of there is not. So we find angles that are between minus 180 and 180 degrees. Well, therefore, what do? I go and I say, right, this angle, no. Tick, 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 and out. This was out and out. Because it is over 180 degrees. Okay. What if I'd have said 270? Then it would have been in, wouldn't it? All right. So in this case here, that's what I chose. If I chose a 270 there, then I would have had the last angle included. There would have been in, but the rest would have been out, right? So those are my angles. How do I finish off this problem? I write this. Okay? I write x, element of, and I put down all of my angles over here. Minus 153.79. Minus 63.79. 26.21. And 116.21. Okay? and I say x is an element of those. I've just said that you've restricted the domain, therefore that is where we're going to end off. Very straightforward. That can be applied to anything. As I say, all it is it's just trying to whittle down what it actually can be. Let's now have a look at something slightly different. We're going to have more complex forms now, all right? We're going to have complex equations. Complex equations, all right? And basically they're going to ask us solve, and there's pages of this which we're going to get through. We're going to go through them all bit by bit by bit, okay? Because there are recipes, and as far as I can, I'm going to use them, okay? But we can only use them up to a point where we have to actually make some judgment calls and get an insight into what is happening here. First of all, what are we used to? Well, step one, always when we've got a complex equation, is we do the following. A, factorize, as usual. Okay? And step one is what? We look for highest common factor. Step two is we look for difference of two squares. Yep, remember I told you factorizing way back, this is even last year's stuff, factorizing is the basics of everything, okay? And that's where we got to focus, because here it comes again, okay? And the same processes apply. Then we can say, all right, the next would be a quadratic. I previously had in mind cubics. And last but not least was number 5 is going to be grouping. Okay? Now, therefore, that's what we're going to look for. So when we get to the more complicated ones, and you'll recognize them straight away, one like this. Here's an example for us. Let's just cut our teeth on a little example. All right? Let's say they say, find the general solution. Find the general solution of 2 cos squared x plus cos x minus 6 equals 0. Let's change it. Come on, let's make it slightly more difficult. Equals 6. Okay? Right. Now we go through and we say, oh, highest common factor. Whoa. What did we say when we did these previously? We said, watch it. That is to the power 2 and 1. Therefore, it is a quadratic. We go through and look for highest common factors, of course. That's what we do. That is step number 1. Difference of 2 squares, no. Highest common factor. It's a pure quadratic equation in this case. Right? How do we solve this? Well, if you really wanted to, you could say, let x equal cos x, right? Therefore, it's going to be 2k squared plus k minus 6 equals 0. And you would then solve, and that gives us this. You'd put in your calculator, or you'd solve it straight out. You'd have 2k minus 3, and you'll have k plus 2 over there, all right? It's better to get used to factorizing it directly, okay? And if you factorize it directly, you are going to get 2 cos x minus 3 and cos x plus 2. Because if we multiply this out, let's just do it just this once, we get 2 cos x times cos x. So you get 2, remember, you put in the little, these guys, remember them coming back again? You say 2 cos x times cos x minus or plus 4 cos x minus 3 cos x minus 6. That's 2 cos squared x plus 4 is plus cos x minus 6. And we're back to the original equation, right? It's easy. Just think of the cos x and the x as being synonymous, right? So you don't have to do a method of substitution with these unless they are particularly evil and nasty, all right? So what do we say? Okay, therefore we have now factorized it. That is equal to 0. So how do we do it? We take the first bracket equal to and the second bracket. So we say, therefore 2 cos x minus 3 must be equal to 0. And cos x plus 2 equals 0. Then I can take that to the other side, and I can say cos x is equal to 3 over 2, and cos x is equal to minus 2. Okay, now, they are now normal trig equations. However, no solution and no solution. Because if you go into your calculator and you press Shift cos 1.5, you get math error. If you push Shift cos minus 2, you get math error. Okay? Why? Because, why is that? Someone tell me from out there. Okay? It's quite simple, really. It's not rocket science. Look at this. Cos x goes from 1 to minus 1. Okay? So therefore, it can never be minus 2 or that. It can only be between 1 and minus 1. So they have no solutions. So your calculator is quite right. You don't have to bother about it. Okay? Let us look at one more of these and then we'll move on to even more complex. Look at this. Sine x times cos x. Example. Sine x times cos x equals cos x. Oh, you think, okay, cool. Hang on. I divide through by cos, right? To cancel it out. No. No. You cannot divide by cos x. Unless. Okay. No, let's just stop with that. You can't divide by cos x. Why? Because cos x could be 0. And you're not allowed to do that. Okay? So you cannot simplify by dividing by cos x here, quite simply because it is possibly 0. So we cannot divide by sine or cos or anything unless they tell us it's not 0. Okay? In which case you can, or you just have to leave it alone. So therefore we would say sine x cos x minus cos x equals 0. Can you see a pattern? We're doing exactly what we did before with equations. And highest common factor, cos x, leaving us with sine x minus 1 equals 0. Therefore split now, because there's a bracket there, cos x equals 0 and sine x equals 1. This is then reference angle here, and then you carry on as normal. Reference angle is 90 degrees and you carry on as usual. All right? I'm going to stop this one here. We're going to now start getting into quite quite heavy ones where we use co-functions, and I'm going to introduce different types to you in the next section. Okay, we've got about, I don't know, 6, 7, 8 examples to do there. They're quite exhaustive ones. When we've done that, you should be able to cater for any type that's available. Cheers, thanks for watching. Have a good time. I would say really thoroughly go and enjoy these, but you know what? They are difficult. That it's not the maths that's that difficult. It's keeping track of the arithmetic on these things that's actually really the irritation portion, right? And yeah, we'll do some heavy ones when we get back. Cheers. Bye for now.